Okay, so this business about functions being equal or not it's quite subtle and it's easy to get confused about it. So two functions are equal if and only if, number one, they have exactly the same domain, completely identical. Number two, the outputs are the same for everything in the domain. So first of all, are these two guys in part A, are they equal functions? Well, they both have exactly the same domain. The domain is equal to all real numbers because they're just polynomial expressions. And anything else? Well, basically algebra tells me for any x they're exactly the same. So x squared plus 2x plus 1 is equal to x plus 1 squared for all x. So these two things together, 1 and 2, imply they're the same function or equal functions. So that doesn't mean they're equal some of the time for some x. It means absolutely they are equal completely. All right, so this is the first guy. Next one. Are these guys equal? Well, they look quite different, but let's just observe a few things. Firstly, the domain of both of them is all real numbers. This ties back into previous example because the only thing that can go wrong really is the denominator here being 0. Well, that denominator is always greater than or equal to 1, so it's never 0. So they both have the same domain, brilliant. Are they equal as functions? Well, we need to think about the algebra here. So x cubed, so I'll bring this all down just so we've got more space. So x cubed plus x divided by x squared plus 1. Well, we can factor out an x on the top. And that gives this. Now, at this stage, you do need to be a little bit careful, right? I desperately want to cancel off that x squared plus 1. Can I do it? Yes, I can. And I can do it for any value of x because it's always non-zero. Okay, so this is a specific piece of algebra. This is the piece of algebra that says a over c over b over c is equal to a over b. Of course, this is if c is not equal to 0. If c was equal to 0, this wouldn't make any sense. But x squared plus 1 is not 0 because it has to be greater than or equal to 0. So bingo, I can cancel the whole thing. So this is true for all x, not just some x. So this implies equal functions. Last example. Okay, now this one's a little bit dangerous, but we can kind of stop the procedure immediately because the domains are not the same, right? So the domain of the first guy is immediately equal to, well, it's all x such that x is not equal to minus 1 because minus 1 would be dividing through by 0. That's the only possible problem, so it's this. Is it to minus 1 union minus 1 to infinity? And of course the domain of the other one is the whole thing, because it's a very simple expression. And these are not equal to each other, right? We've lost minus 1. So this implies they are not equal as functions. Now the trap is the following. So I've got to be super careful up here. Maybe I'll make this a little bit smaller so we can see it. So it can fit. So the warning is the following. You might factor this to start like this. Yeah? It's the difference of two squares. And then it's terribly tempting to say, okay, I'm just going to cancel that off, and this is going to be equal to x minus 1. So the algebra tells me they're equal to each other. But remember what we've just done. The only way you could cancel this off is if your c, i.e. your x plus 1 in this case, is non-zero. But if x is equal to minus 1, this fails. Okay, so this is only true only for x not equal to minus 1. If x is equal to minus 1, there's no equality. One side doesn't even make sense. So this is kind of a really subtle point, and it's quite pedantic in some ways, but at the same time, it's really making sure we understand the finer details of what functions are all about, which really matters, right? This isn't just a question of blindly doing calculations. You've got to really understand what the concepts you're dealing with are.